We're told that the cylinder has a volume of 78 cubic centimeters, and they're asking what is the volume of the cone if they have the same radius and the same height. Remember, we watched that video that showed us that a cone and a cylinder of the same stature will show that the cone is only 1/3 of the cylinder. Therefore, I just needed to divide my volume by 3 to find that the volume of the cone is 26 cubic centimeters. You can see which options I chose, but let me walk through it. First, this one says the relationship between the radius and volume is linear. Obviously, it's not linear because we can see it makes a curve. This one says if the radius of the cone doubles, then the volume of the cone also doubles. Where this says if the radius doubles, then the volume of the cone is multiplied by 4. If you don't remember these facts from class, then you could look at an example in the graph. What I did here was I found a radius, and then I found a radius that was double that. And I'm going to use those to compare the volumes. So when the radius was 1, it looks like the volume was about 6, but then when we doubled the radius, we compare that, and it looks like it's a hair below 25 for the volume. So the volume for that one is about 25, and sure enough, 6 times 4 is 24, but as I mentioned earlier, we were kind of estimating what these volumes were. So I think it's safe to say that when we doubled the radius, we went from 1 to 2, we doubled that radius, we did see that the volume roughly multiplied by 4. So that's why I chose this option and not this one. And then moving on, it says here the relationship between the radius and volume is nonlinear. Yes, we can see that. It creates a curve. And then here it says if the radius of the cone is 2 inches, the volume of the cone is about 25. Well, we can find that on our graph. Go to a radius of 2, go up to find the volume, and we can see that that is also true. It is about 25 cubic inches. I'd like to start this problem by saying almost everyone chose either this answer or this answer. And you'll see in my work why these were the two popular answers, but only one of them is correct. So I start with my sphere formula, substitute the radius that was given to us. Please notice the radius is cubed in these problems. Then I simplified the 2.7 raised to the 3rd power, and then I combined my 4/3 and my 19.683 just to simplify it. So I multiplied those together, giving me 26.24, still times pi. And then it says here, what is the volume to the nearest cubic centimeter? That means we need to find the answer. Do not leave it in terms of pi. So we need to go one step further, and in our calculators do this 26 and change times pi, and when we do that, we get our volume, which is roughly 82 cubic centimeters. So as you can see, 82 was the volume. However, many of you chose the 26 because you were looking here in terms of pi. The answer was 26 pi. And I remember that was a common mistake in class, that many of you were forgetting to bring down your pi into your answer. Now on number 4, you may have had this equation, or you may have had another equation that looks very similar, because this was one of the problems on the test where Canvas selected a random equation for each of you. So if this was not your equation, I apologize, but the process is still the same. So we had this equation for a cone. We already accounted for our radius, and it's simplified to this formula. Our goal was to fill out the table in hopes that we could create a graph. So I started by filling in my table with some heights. I just copied those x values from my graph, and then I went ahead and substituted them into the formula. So for the first one, I did 12 pi times 1, and that gave me an answer of 12 pi. And then the next one would be 12 pi times a height of 2. And when I did that, I got 24 pi, etc., etc. Now you'll also notice that I found the approximate answer. I did not leave it in terms of pi because my y-axis is not in terms of pi. They gave us the actual values of the volume. So I did these in my calculator to find those approximate values, and then based on that I went ahead and graphed my points. When we had a height of 1, we had a volume of roughly 38, so I plotted that there, and you can see how the rest of my graph came together. Now the follow-up question says, is there a linear relationship between the height and the volume of the cone? Yes, we can clearly see that it does make a line. Now if yours did not quite make a line, say there was a little bit of squiggling in here, you can see that it is linear because it goes up at a constant rate. It clearly goes up by 12 pi each time. This went up 12 pi, another 12 pi, another 12 pi, another 12 pi. So I said yes, there is a linear relationship because the volume increases at a constant rate of 12 pi. Here it says a cylinder has a radius of 1.6 meters and its volume is 95 cubic meters. We need to find its height. So first I started with my equation and I substituted the volume and the radius. And the first thing I'm going to do is square this here. And 1.6 squared creates 2.56 times pi times h. So we want to get h alone, and since these numbers are attached by multiplication, we're going to get rid of them by dividing. And then you can see here that our pi's cancel out, our numbers cancel out, and then on this side we do not have a pi to cancel with this pi, so in our calculators we need to divide by both of these numbers. So that's why I've put the parentheses here. Now you'll notice if we do it the correct way, 95 divided by that whole group in parentheses, we get the correct answer of 11.8. But just notice that with this calculator here, had you not put the parentheses, you would have ended up getting a wrong answer. And what the calculator did here was it did 95 divided by 2.56 and then multiplied by the pi. But here we need it to divide by it. Here on this problem, we're told that two cones have the same volume. They gave us the radius and the height of cone A, but we need to find a different radius and a different height for cone B that makes the same volume of 48 pi. Now, the biggest mistake that I saw when grading this question was that most people forgot that the cone formula includes 1/3, and therefore their dimensions worked for a cylinder with a volume of 48 pi, but we need the cone to have a volume of 48 pi. So I have two examples here, and this is just one way you could have done it. I would have substituted the volume, 48 pi, that's what we needed, kept our formula, and then just pick a number for the radius. You could pick any number for the radius. My thought is, let's start with a radius, and then we'll go through and solve what the height would be to go with this radius that makes 48 pi. So you could have chosen any number. So I chose 2, so let's see what happens. First I'll square this, which makes 4, and then I need to get the height alone, so I'll divide by all of these numbers since they're attached by multiplication. And when I do that, on this side, these numbers cancel out, which is what I wanted. Over here, our pi's cancel out, and I now need to divide 48 by 4 times 1/3. This is not 4 and 1/3. This is 4 times 1/3, because remember all of these numbers were being multiplied. And when you do that in your calculator, you should get a height of 36. Therefore, a different radius and height that we found was a radius of 2 and a height of 36. If you need to check your work, you could absolutely plug these back into the equation just to ensure that it did make 48 pi. Now I'll just show you that this could work by using a different number. I did the exact same thing here, plugged in the volume, but I chose a radius now of 3. As I said earlier, you could choose any number for the radius. One more time, I simplified that radius squared, then I divided by all of those values, and when I did that, I ended up doing 48 divided by 9 times 1/3, and my calculator told me the height was 16. So that told me that with a radius of 3, the cone would have to have a height of 16 in order to make that volume of 48 pi. Here we're given an absolute value problem, and remember absolute value is distance from 0. As a reminder, you can only have a positive distance, so keep that in mind as we go through this. So our first step is to isolate, and remember to isolate means to get these bars alone. Therefore, we need to get rid of this times -3. So the opposite of multiplying by -3 is dividing by it. Those -3's cancel out on this side, and we're left with -9. Now our bars are isolated, which is what we wanted. So now we have the judge step. And in the judge step, we ask ourselves, is it possible to have a distance of -9? Or can you be -9 spaces away from 0? And the answer is no, because your distance cannot be negative. Therefore, we're done, and we say there are no solutions. Here we have another absolute value problem. If this is not the exact same one you had on your test, that's okay. You had one very similar to this. Remember our first step is to isolate. That means we have to get these bars by themselves. Now, that means we need to get rid of the -4 and the times 6. I will remind you that when solving equations, we're doing PEMDAS backwards because we're going backwards to find the missing number. So with that said, I'm going to get rid of my subtraction, and then I will get rid of that multiplying by 6 by dividing by 6 on both sides. And that leaves me with this line here. The absolute value bars are isolated, so that step is complete. And now I move on to the judge step. And this is where I ask, is it possible for something to have a distance of 3 spaces from 0? Can you be 3 spaces away from 0? And the answer is yes, because you can always have a positive distance. Therefore, we have to now move on to the next step, which is to split. And when we're splitting, we're saying, okay, if this guy is 3 spaces from 0, then where could he be sitting? He could be sitting at 3, because that's 3 spaces from 0, or this guy could be sitting at -3, because that's also 3 spaces away from 0. Once we have our two separate equations, then we just solve them independently of each other. Notice I got rid of my subtraction, then I got rid of my multiplication by dividing, and that gave us the final answers that x could be 3 or x could be 5.